Thank you for attending this presentation. My name is Javier Alvarez, and I will talk on behalf of Emmanuel Maqueda and Vladimir Meza. Our topic is tools forensic speaker identification in Spanish using triplet loss. This is the outline of the presentation. First, the introduction, then methodology, results, and conclusion. First, the main points of our work are these. Speaker identification in Spanish, as its name says, is the identification of a Spanish speaker by using his or her voice. The word forensic adds some constraints. If we want a forensic speaker identification, we need to be able not only to match two voices by their similarity, but also to quantify the chances of the recordings to be confused with recordings of a different speaker. Triplet loss is a loss function that uses three vectors. The first two vectors correspond to one object, while the third vector corresponds to the representation of a different object. The goal of triplet loss is to enforce that the representation of the same object are close in relation with another object. Methodology. Our dataset was VoxForge. VoxForge is a collection of donated voices used to be a free open source tool. It contains 2,180 speakers in Spanish with 20,692 recordings, and in average, every recording has a duration of 8.25 seconds. The data was split in 80% training, 10% validation, and 10% testing. We took every recording and transformed them to spectrograms. One spectrogram was an image of 200 per 256 pixels, and this was the input of our model. The model was a neural network with 5 convolutional layers. The first 2 layers were made with 32 kernels, while the 3 last layers were made with 64 kernels. After every layer, there was a back normalization, a max poly of size 2, and a ReLU activation function. The output of our model was a one-dimensional vector with 1,024 entries. We decided to take different values of the margin, which is the distance of 2 different speakers must have in order to be considered different speakers. The values that we decided to try were 0.2, 0.5, and 0.8. Then we had to make some tests in order to evaluate our results. We decided to use these metrics: the inner average distance for speakers, the outer average distance between different speakers, as similar to the likelihood ratio, and the mean silhouette coefficient. As we can see on the table, the greater the margin, also the greater the outer average distance. This means that our model works better with greater values of margin. So we decided to take the 0.8 and we did this 2D projection. In this projection, every color represents a different speaker, and as we can see, it is fairly easy to identify different speakers. However, especially in the center, there is still some overlap among speakers. So we have to improve our model a little bit more. This takes us to the conclusions. In first place, we were able to successfully use a triplet loss network setting for forensic identification on speakers. Also, in our model, a larger margin for the loss gives better results. However, we still have some overlap among the speakers. And in future work, in order to fix this overlap, we will focus on introducing new methods to train the triplet loss. These are the basic references, and that's it. Thank you.